Yes, folks. Hume again. How are you going? So we're continuing with our series where we're discussing powers, indices, exponents. And we're going. Rule number 4. Rule number 4 says that a to the power of m in brackets all to the power of n is equal to a to the power of m multiplied by n. Examples. So instead of talking, let me do some examples now. Yeah. So if I have 5 squared and everything in the bracket is raised to the power of 3, then that would be 5 to the power of 2 by 3, which is 5 to the power of 6. If I have 19 to the power of minus 1, all to be squared, that is 19 to the power of minus 1 by 2, which is 19 to the power of minus 2. If I have 8 to the power of a half, all in brackets to the power of 3, then that would be 8, that 8 leaning so high, 8 to the power of a half by 3, which would be 8 to the power of 3 over 2. Alright? You multiply a half by 3 and I get 3 over 2. We'll deal with multiplication of fractions and stuff as a separate matter. So I just putting it out here. If at this point here you have an issue, make a note of it, treat it as a separate enterprise and deal with that separately. But I'm just giving you what happens when you have the different powers. We do our all minus now. How about the all minus? So if we have, for example, that 6 to the power of minus 4, all in brackets to the power of minus 2, then yes, what that would be 6 to the power of minus 4 multiplied by minus 2, which would be 6 to the power of 8. Same rules. Power inside, all, and then you have another power outside. You multiply the two powers. Yeah? And that is it, you know. That is it. Alright? So, let me see, what is the multiplicative analog to this? I'm just using some fancy vocabulary here, but don't worry about it too much. So if I say, don't worry about it because I'm trying to illustrate, right? I'm trying to go as deep as is practical. It might be a little deeper than you would go in most places. If it's too deep, don't worry about it too much. Just focus on this, right? But I know there are some of us who have a little extra curiosity and are trying to throw a little something out for you too. Yeah? So if we have MA multiply by N, then that would be not MA, with my little cloth here. Sometimes the little old cloth does do the job better than the fancy dusters, you know. Yeah, boy. So if I have AM, A multiplied by M in brackets, and all that is multiplied by N, then that will be AMN. See? It is similar, it looks similar, it appears similar. But in terms of what it actually is, it is a horse of an entirely different color. So let me illustrate the difference between those two. Alright, now I'm going to wet this cloth a little bit. Alright, taking your deep into the heart of the operation here now. Right? Sometimes you have to wet the cloth to rub off the board and ting. Yes? Right, so we're good. So what are we going to do here now? And now that we rub off the board with our wet cloth, we have to find ourselves a dry cloth. Because if we leave that on the board to take its cool time, by the time it's ready, that is a whole different story. So here what? Let me take a dry cloth now and try and accelerate the process. Alright? So I'm going to indulge in a little bit of vocabulary now. So in other words, we're going to vocabularize the mathematics. Because sometimes when you vocabularize it, it helps in your understanding, it helps in your thought process, it helps in making things clearer. So, my red marker, boy. Oh, it's in my hand. Watch. You see? Yeah, that's how it be sometimes. Ha! So, this here is the exponentiation as we discussed. Alright? This here, watch the vocabulary carefully, is the multiplicative analog. In other words, we're making an analogy of this using multiplication. See? Right. Let me just examine the difference between these two, just to drive the point home. What color are we going to use now, boy? Let me hit them a little green now. What let's see. We have some green still. Using this, let me use some simplest numbers now. Let me say 4. Let me use 2. In all the examples I used up to this point, I haven't used 2 yet. So let me use 2. If I say 2 to the power of 3 in brackets squared, that is 2 to the power of 3 multiplied by 2, that is equal to 2 to the power of 6, that is equal to 64. Alright? 2 to the power of 6 is equal to 64. That's this guy here. Right? If I do this now, multiplication, 2 by 6, and then we multiply by, sorry, not 2 by 6, 2 by 3, and then we multiply by 2 on the outside here, that will be 2 by 3 by 2, which is equal to 2 by 6, and 2 by 6 is 12. Big, 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 big difference. You see? So, the reason why I'm making the extra step whenever I can to demonstrate the difference between the exponential and the multiplication, the exponentiation, sorry, the powers, and its multiplicative analog, is that these are simple mistakes that people make. Right? Somebody would see this. Somebody would see this and they might end up writing this. Just as I would have made the explanation in the video where I spoke about the difference between multiplication and exponentiation. Sometimes the cause of the error is as simple as how you write the thing, you know. If you write the powers big enough, just as I explained in the video, you might end up mistaking it for multiplication. And then once you start to multiply, you're using a totally different set of rules, which would give you the wrong answer if the original question was a question on exponents. So you have to be very, very careful. Careful in terms of how you're reading the question. Careful in terms of how you're writing the question down. And then once you read it properly and you write it properly, then you just take your time now and apply the appropriate rules. So you see the difference between exponentiation and the multiplication. Now, another mistake that people make is the following. Right, we could rub you off now. Alright? Another mistake that people make, so you see, all they getting the rules, all they getting common mistakes, all they could want it better than that. Alright? So let's stay tuned now. But yeah, stay tuned. Stay tuned. If you're on YouTube, subscribe to the channel. Click the notifications. If you're on Facebook, like the Facebook page. Share it. Click the notifications. Plenty good stuff here. So, another mistake that people make when they're dealing with these things is the following. Sometimes they'll see this and confuse it with the second rule that we did, where we had we more multiplying two common bases. So people will do this. They would see a to the power of m, all in brackets to the power of m. They see the m and the n next to each other. Well, from a generalistic kind of viewpoint, even if you have some level of familiarity and you're not totally familiar with the whole thing, once you get to a certain point, you know at this point is only one or two things going to happen. You're either going to multiply the powers or add the powers. You kind of have a sense of that. Right? So some people will do this. They'll put a to the power of m plus n here. Problem. Don't make that mistake at all. At all. Alright? This is not to be confused with a to the power of m multiplied by a to the power of n equal a to the power of m plus n. Don't mix them two up at all. Alright? And all of this is why we need to practice. Because if you just watch the video and you say, yeah boy, I like the video, he explained it real nice, I understand it. Of course you understand it. You understand it when I say it. When you're by yourself and you have to pull the rule out of the hat, either by memory or by developing it. But at this stage we're dealing more with memory because I give you the rules and they're memorized by practice. When you have to deal with that by yourself, that's a whole totally different matter. And there are so many things in life that the learning involves a similar process. So if you learn to drive, for example, you might watch a YouTube video and drive in. You might watch a documentary and drive in. You might sit down in the car and somebody driving and you're watching them and you say, yeah boy, I feel I could do that. And then when they put you in the seat to do it, you suddenly realize that there are a whole host of other variables that you was not even aware of. As a passenger, that you only become aware of when you become the driver yourself. Same thing with, let me say, you learn to play a musical instrument. You have the best professor in the world, no problem. You understand everything. He break it down nice. Or she. Right? He or she. You watch a nice YouTube video, you watch a documentary, whatever. You have a friend who plays the instruments or whatever. Yeah, but then you have to pick up the instrument and play it yourself. Not so? And there's a whole, listen man, that's a whole different story by itself. So I wanted to think of the maths like that. I wanted to approach the maths like that. Do not satisfy yourself with just watching a YouTube video and understand it. You ain't even start yet. Yes, in some ways you start, but in other ways you ain't start. Because to get to the point where you understand it, one, and where two, you could answer a question and express your understanding under pressure, which generally speaking in academic circles would be an exam of some form or the other. Written exam, oral exam, take-home exam, whatever. online exam. Then you really get to the level that we want you to be at, where you could express yourself under pressure, where you have a time restriction, you don't have the whole day to answer a question, right? Where you have no control over what the person is going to ask, but they ask something and you now have to figure out what they're asking and respond to it. That's a different level, and that of and by itself is something that you have to practice, and you have to practice repeatedly. So I'll take a little extra time just to give all a little advisement, so to speak, of the psychology of learning mathematics. Yeah? Right, so just to reiterate, do not confuse this. Sorry, do not confuse do not make this mistake. Let me just leave it like that. A to the power of m, anything inside. So in other words, just use a real number that you could relate to. Right? Sometimes people need to see the actual number. 4 to the power of 3 all raised to the power of 4 is not 4 to the power of 3 plus 4 equal 4 to the 7. Right? Is not. What it is would be that 4 to the power of 3, all in brackets, to the power of 4 would be 4 to the power of 3 by 4, which is 4 to the power of 12. Don't make this mistake at all, please. Alright, nice. So with that being said, we move on to the next rule. And here's where the things start to get nice. And you'll see what I mean.